My name is Log51Tablesbig. My talk is devoted to the new MySQL feature. This is log tables. I'm from Moscow, Russia, and I work for Google. Previously, I worked for MySQL, and back then I wrote the log tables. So first, I will tell a little about MySQL logs, what kind of logs does MySQL have. Then I will show how one can use this new feature. And at the end, probably we will discuss what else can we do that can we improve it somehow. So, let us start. MySQL, there are two kind of logs. First one is just text-based logs which go to files which you can easily read by viewing the file. And completely different kind of log is binary log which is used for updating replication, which we will not cover in this talk. So let's take a look at what are these logs, how do they look, and what good and bad things about them. So the error log actually originally just captured was applied to the MySQL, the safe MySQL script which ran the server on Unix, which simply captured all the server output. So the error log is essentially just capture of what server prints on the screen. And there are some problems with it. Mainly, the main problem is that it is not structured and you don't really know what could be in the error log because different subsystems of the server print information to it. And it is written in the way these particular subsystem wants to do it. So if you want to look through it to find something that's not very easy with automatic prints. So this is how it looks in the files. So you can see that these records are more or less structured. There is a timestamp here, then information about what server did. Unfortunately, this is because the messages are printed by the core MySQL subsystem. But other subsystems such as UnityD, for instance, print it as a blast. It pretty prints something sometimes. There is no way to analyze it except for just reading this code. So the second kind of log is the slow log, which you can use to determine the queries which run too long. Usually you need it to improve the performance of the database or whatever. You can set the long query time variable and find out the queries which run longer than this. This also goes to files, and this is how they look. Here is the structure. It always looks this way. However, the data which is written is not the same. It depends on what kind of query it was. So there could be additional fields here, or it could less some fields depending on the query. So the general log finally. General log just captures everything you print into a server. If you log in into it and write with the MySQL client, find something, press enter, this will be in general log. And it writes it as log as soon as it receives it. It just doesn't even try to find out if this will work or not. Errors will go to the general log as well. And obviously, on a lot of databases, it goes very, very fast, so you need to rotate it often. And either put it to the backup tape or just remove it after some time. So this is how it looks. The timestamp, the kind of operation which happens to the database, for instance, connection, and the queries with the SQL text. As you see again, there are rows with no timestamp. This means that it was the same second. This saves space, but again, if you want to write something which extracts information from the log, you get a problem because the rows are not the same. And finally, as binary log captures also a lot of information, there is slightly highlighted differences. As binary log is used for backup and replication, it logs only changes to the data. It doesn't log reads and so forth. Also, it writes the records in a different order. So it writes the records to the general log when they arrive, and in case of the binary log, they go to the log only after they execute it. So what are the problems with these logs? Why do we need to improve something? Well, first, the logs are very poorly structured. So if you have to get some information from it, we mostly have to just read it through. And these are, sometimes they're very, very long. And it's not very convenient. It also requires user-level access to the system. And in some cases, you cannot give it. For instance, if you're a hoster and you're giving access to a database to external people, you don't want to give them user-level access because it's, well, it's a security issue. Again, as these are files, so you can do very little thing about it from the database. You have not only administer the database, but deal with the system. So you have to write scripts which will rotate logs and so forth. And of course, there is no way for the server itself to find out something about itself. So now when we have, nice group has stored procedures and events and so forth, it's natural to have the data about what happens with database in the database. And with logs, which are just files, we cannot use them. So that's why the log tables were introduced. Slow and general logs were converted to the tables, and now you can use ordinary SQL statements to deal with it. So for instance, you can just check if someone accesses a secret table which contains some very important information and whatever. And you don't have to grab through the files and so forth. So what else can I say? What else features do it have? So first, you can of course control the access to the log files with SQL statements using grant statements. Another thing which was introduced in 5.1 is the ability to disable and enable logs on the fly. It was missing previously, which basically meant that if you want to log something into your system, you have to stop it, then enable logging, and then start it again. This is almost impossible in production systems with have a log. You can't just stop it. Now it is possible. You can start logging, then check what's going on with the server, stop logging, and analyze it later, which is nice. And finally, you can use several storage engines to store actual logs. This is either new engine CSV or all good MyISO. So I will talk about what the difference between them and how would we like to use them closely. So who might need them? Well, first, hosters can use them just to give more flexibility to people who write software, and so that they can find out what's happening with their system. And the second category is probably that people who will benefit more from this feature is application developers, because well, you cannot really write an application which logs into systems and reads the file, but you can write an application which connects to the database and retrieves some data, which is very natural use. And with logs, finally, applications can do something about logs. For instance, with a slow log, an application which controls the database server can say that something is wrong or whatever. Well, and of course DBAs. First, well, they don't have to have a separate secure shell connection to read the logs. You can just do it from the database. And more importantly, you can use it in joint with new events feature of MySQL 5.1. For instance, you can do automatic log rotation without relying on any external tools, or even do some special performance-related configuration. For instance, you can write an event which once in a week checks if there is something in the slow log, and if there is, try to analyze it and probably improve some server parameters on the fly, and you don't have to do it manually. So the implementation is more or less straightforward. There is a special object called logger, and there is an interface to it. All log events go to it. And for slow and general logs, there is a way to between two destinations. You can either write it to the table or to the file. So there is a special mutex which controls the access to the object, and all the data comes in, and then either goes to file, to table, or to both. So obviously, because of the mutex, all operations are serialized, and so we are sure that there will be no collision because of the concurrent access to the logger. And another more important issue is that when logging is enabled, the logger, which is a special entity with a database that has an artificial thread associated with it, it logs the tables, the log tables with the special log which does not allow updates. So when the logging is enabled, there is no way to update the data. So some people like it because there is a guarantee that when you have logging enabled, that nothing will be changed. So it's kind of a security thing that the logs will be just the same as were written. Others say that this is a natural limitation and that we should somehow enable updates. So here are several practical things. Due to this limitation, there are some very basic operations. So operations require special setup. For instance, if you want to change log, you have first to disable logging, because otherwise the log and log tables will not allow you to change the engine of the logs. So here how to do it in a safe way. You just save the state of the slow logs, for instance, then change the instance data, for instance, from C3 to MySQL, and then you put the state back. Again, because of the fact that the log tables are logged, you have to use special atomic operation to replace logs, which is rename. So you cannot just copy some query, then delete them from the table, because they are logged and there is no way to update them. So you have to use rename. So what are these two engines, MySQL and C3? C3 is a new small engine which simply writes data in a comma-separated value format. So just files with rows where you have the information which the row is going to log. So you can just edit it with your favorite editor and read it. To a great extent, for people who got used to the old logging, this will be a nice feature. So if you want to log anything, you enable logs and you can either use database or just go and read it. Well, but the pitfall, and because of this, it's slow and it has limited functionality and indexing and so forth. So if you need to log small amounts of data, then analyze it, then probably C3 is the right choice. But if you are going to enable the log for a long time, then most likely you will need to use MySQL. Basically, well, it's obvious that it is fast, it supports indices, it is more space efficient, but it's if you expect the log files to be readable, as they always were with older versions, and you didn't just notice this change that now they are tables, you'll be hit by this. There is no way to read it, you have to learn SQL to read the logs and so forth. So, how can you use events, these new events with log tables? First, several words about what it actually is. The event scheduler runs some tasks according to schedule and looks pretty much like Crontab or Windows task scheduler, but it's embedded in the database. It is a separate thread in the database which from time to time checks these tasks and runs them. So with logs, you can automate many tasks. For instance, the log rotation is very easily done with events, and it does not require external scripts. Here is how to do it. So just create an event which runs every day, and in this particular case we just drop the old log and create a new one. But in the real world scenario, you can keep them for a week, and that's the simplest way to rotate logs. And this way you don't have to mess with the file system, with external scripts, and you don't know how they work with so forth. So backwards compatibility. So if you use CSV logs, they're just human readable because the format is different. That's why the original plan was to deprecate the old logs completely. But still, as there are applications which still use the old logs somehow, it is possible to preserve it. You can just specify the file, and it will go to the old style log files. So, and you can enable both. But of course that will consume a lot of space and not very efficient. So what can we do with logs? This is, what else can we do? The first thing which comes into mind that we can go Mascot has a bug file in it, that it would be nice to have the modifiable. So if anybody has strong opinion about it here, it would be nice to hear it. I personally don't find this very useful, and if someone else in this scenario when it could be needed, I'd like to hear it. So another extension is just to add these tables to the information schema as all the information about the database is collected in this virtual database. It might make sense to link the log tables there as well. Another way is to add some more tables, and about some of them there were requests such as audit log, but the audit log is essentially a log which captures everything about the server, what happens in it, and it doesn't change. So it's like a general log, but it contains more information. It is useful for features such as, well, there are some certain situations when you have to prove that everything is okay with the database. Usually it happens with business applications. If it is something about money and so forth, you have to prove that nothing wrong happened to it. In this case, you would have to present it. So with log tables, it would be more or less easy to add a special kind of table where all this information comes and additional ones from applications. And it does not change. So if the audit log enabled, then you get all this information and can prove that it's okay with the database. Again, if anybody finds this useful, please say so. So it also might make sense to export the big log through the table to check what's in. So another way to probably improve it would be have more storage engines supported by the log tables. For instance, Falcon or NDB or NDB, so that you can use, for instance, in the case of NDB, the basic means that the logs are distributed, that there is a fast access to them, and so forth. The question is, when you're developing something, the question is whether people need this, and it's hard to say it when you just code. So again, if there is anybody with practical experience who knows that this is required, then please say so. So, where you can read more about log tables? There is not much to read. First, this is MySQL documentation, where is the information about them. You can also read about event scheduler to find out what else you can do with the log tables. And finally, there is the log tables usability report by Zepmc, who is here. So you can ask him, or you can do it already. So, I want also to thank the people who helped me with design and code reviews. They are listed here. It's Sergey Golubchik, Konstantin Osip, or Lars Storman, who was present on this conference. And they welcome the code here, so unfortunately they are not in this room. Thanks to them. And Simon Dalton, who didn't come this time. So I also would like to thank Giuseppe, who helped me with preparing this presentation, and of of course my employer, Google, who sponsored that visit to the conference. So, any questions? Yes?
Is it possible to do the same loading technique like for multiple servers? For example, so if I can dedicate one server to be like a local loader for my system?
Well, how do they connect it? You mean if you have a replication in place or what?
It's, for example, replication. And I want the slaves to be reported some slow queries.
There is no special technique for it, but if you have scale out solution, for instance, with a master and a lot of slaves, of course you can enable the log on only one slave and automatically all the information will go to it. So, of course you will not know if a particular machine is slow without enabling an average from them. But most likely, if they are just the same, you will get this information.
The question is, I want to have error logs from multiple boxes in one box, like loader box.
Error logs.
Yes.
Well, first error logs are not, there is no table for error log. So it's just file as it used to be. So the answer is no. Oh, okay, that will be you.
A question based on what you just asked. What if you define the general log or slow query log or the error log as a federated table? Could you then have multiple servers logging to one server?
Well, I didn't try. So Giuseppe said that, well, it doesn't work.
Okay.
Yes?
Yes, part of the table logging works since the tables are -n. So if you're querying against the error log table, will that affect the regular objects?
Well, again, there is no error log table, there is general.
Not the error log,
If,
general log.
well, it goes to the, if you query for the general log, this very query will go to the general log. But as I just said, there is a special dedicated thread in the server which logs it. So first it goes to the log, and then all the signal processing comes. So when you ask for a query, when you issue a query, it first goes to the log, and then it will be processed by the server. Yes? Pardon? So you mean the CPU goes higher? Well, did you try CSV or MySQL? For what? Well, that's obviously because every query then goes straight into the log. So if you want to log everything, this will be additional overhead. That's obvious. That's why production systems usually is disabled. No, it just changes the format it has, so you can also use SQL. Okay.
Yeah. Are there plans to support the federated
I don't think so. The problem is, well, I don't really know because I don't work for MySQL, so it's hard to say, but I would say no, because the very federated engine is not very complete. So I would either add more solid storage engines such as InnoDB or NDB. So that would either, I don't know what MySQL would be. So yes.
Was the decision to restrict logging to a single thread compromise the fact that MySQL is significant not transactional?
Once again.
It would seem that you shouldn't serialize log access and that you were using a transactional storage engine.
Yes, but both of them are not transactional. The CSV and MySQL, if you enable NDB, then you can dynamic immutable access, the log table is supposed to be updatable and so forth. That's why enabling, adding more storage engines looks very promising. It could add more functionality at low cost. So, yes.
Do the logs get replicated to a slave server program?
No. Well, that's obviously because the slaves can have their own errors and their own slow queries and so forth. So, any more questions? Yes.
Your model from your earlier slides indicated that you were logging before the execution, so
The general log.
the general log. Okay. So does the story change if you start to implement the transactional engines like DD or Falcon where you can roll back various operations?
Well, there are certain issues with implementing. It's not like you can just add another storage engine instead of MySM and it will just work. The reason why MySM and CSV work together so well that they support the same locking system. So there is a special lock which is called concurrent insert lock, which allows reading and adding at the end of the table. So that's why it is so easy to switch them. With transactional engines, of course, there will be difficulties, and of course, you will have to keep in mind that this is transactional. So either it should be you disable. So it won't be a transaction, so it won't be part of the query, but it will use the roller locking, for instance, so that you can use this, so that you can make the tables updatable this way. If you have roller locking, you don't have to lock all the table, and also you can just commit when you write this one line, and even if the server crashes, you can recover it later. So, more questions? Okay, looks done with your week. Thank you so much.